Number 1, use the special right triangles to compute the following expressions. So the first expression is 2 cosine of 30 degrees minus the tangent of 60. Well, I'm clearly going to need a 30, 60, 90 right triangle here. 30, 60, 90. The hypotenuse is 2, the side across from 1, the side across from 30 is 1, and across from 60 is radical 3. The cosine of 30. Cosine is the adjacent over the hypotenuse. So I'm sitting here at 30. The adjacent is radical 3 over 2. So 2 times radical 3 over 2, that's the cosine of 30, radical 3 over 2, minus the tangent of 60. Tangent is opposite over adjacent. So I'm sitting over here at 60. What's opposite 60? Radical 3 over 1. Well, 2 divided by 2 is 1, so I have radical 3 minus radical 3, which is 0. So 2 cosine of 30 minus the tangent of 60 equals 0. Now we need to find the sine of 30 squared plus the cosine of 30 squared. So the sine of 30, well, if I'm sitting over here at 30, the sine of that angle is the opposite, so 1 over the hypotenuse. 1/2 squared. The cosine of 30 is adjacent over hypotenuse. Radical 3 over 2 squared. Well, 1/2 squared is 1/2 times 1/2, which is better known as a fourth. Radical 3 squared is 3 over 2 squared is 4. 1/4 plus 3/4 gave us 1. So sine of 30 squared plus the cosine of 30 squared equals 1. And we didn't need to memorize anything there. We just needed to know how to use our 30, 60, 90 right triangle here. Number 2, consider the right triangle with acute angles alpha and beta. Find the following values based on the triangles below. So this is the Greek letter alpha, and that is the Greek letter beta. And we want to find the sine of alpha. Well, we know, so I'm sitting over here at alpha, and sine is opposite over hypotenuse. Well, I don't know what the hypotenuse is. I know the two legs. So if I know two sides of a right triangle, we can use the Pythagorean theorem to get the third side. A squared plus b squared is c squared. I don't know what the hypotenuse is, so 4 squared plus 6 squared is the hypotenuse squared. 16 plus 36. C squared gives us 52. So when I take the square root of 52, that's radical 4 times radical 13, so 2 radical 13, if we want it in simplest radical form, which is always a good idea. So the sine of alpha is opposite over hypotenuse. 6 over 2 radical 13. 6 divided by 2 is, so this is 3 over radical 13. And for now, I'm going to say it's okay to leave that radical in the denominator. At some point, we will discuss how to get that radical out of the denominator, but for now, we can leave it. But I want to focus on the trigonometry, not on the random little skills. The cosine of alpha. The cosine of alpha, I'm still sitting at alpha here, is adjacent over hypotenuse. Adjacent over the hypotenuse. So 4 divided by 2 is 2 over radical 13. Tan of alpha. The tangent of alpha, well, tangent is opposite over adjacent, 6 over 4, which is better known as 3/2. So those are the sine, cosine, and tangent with respect to alpha. So now let's find the sine, cosine, and tangent with respect to beta. So now I'm going to forget that I was sitting at alpha. I'm now going to sit at beta. Sine is still opposite over hypotenuse, except the opposite side now is 4. So 4 over 2 radical 13, which is 2 over radical 13. Hopefully you notice some connection between the cosine of alpha and the sine of beta. You talked about that last year in Common Core Geometry. The cosine of beta, adjacent over hypotenuse, 6 over 2 radical 13, which is 3 over radical 13. Again, notice the connection between the cosine of beta and the sine of alpha. There's some relationship here that we're going to explore at the end of this homework set, but you talked about this last year in Common Core Geometry. Tan beta. Tan beta is opposite over adjacent. What is opposite of beta? 4 over 6, so 2/3. So we need to be pretty fluent at finding the sine, cosine, and tangent of any angle when you have two sides, because you can always find the third side of a right triangle by using the good old Pythagorean theorem. Number 3, let theta be an acute angle in a right triangle. If the cosine of theta is 4/5, find the value of sine theta and tangent of theta. So we have a right triangle. I'm going to start with that. And I have an angle named theta in this right triangle. We know that the cosine of theta is 4/5, so the ratio of the adjacent over the hypotenuse is 4/5. Now you could pick any numbers that you want for the adjacent side of theta and the hypotenuse of theta as long as that ratio is 4/5. But I'm going to make it nice and easy and go with 4 as the adjacent and 5 as the hypotenuse, because those two sides are in a ratio of 4 to 5. I want to find the value of sine of theta and tangent of theta. Well, to find the sine of theta, I need to do the opposite over the hypotenuse. Well, I have no idea what the opposite is, so if I have two sides in a right triangle, we could use the Pythagorean theorem to find the third side. And we know that it's leg squared, so x squared plus the other leg squared plus 4 squared equals 5 squared. X squared plus 16 equals 25, so x squared equals 9. So x equals 3 because -3 wouldn't make sense to be the side of a right triangle. So that tells me the sine of theta, the sine of my angle, is 3/5, 3 over 5. The tangent of my angle is opposite over adjacent, which is 3/4. Consider right triangles cat and dog shown below. Explain how you know that theta does not equal phi. This is the Greek letter phi, and it is also used to represent angles, just as theta is. So how do I know that theta and phi are not equal? Well, if I look at these two triangles, I know that OG, side OG, is twice the length of side AT. Those are in a 1:2 ratio. If this side's 16, then this side would have to be 32. That side is not 32, so triangle cat is not similar to triangle dog. These two triangles are not similar because their sides are not in proportion. We know the tangent of theta is 4/16, which is better known as 1/4, and the tangent of phi there is 8 over 20. 8 over 20 is 2/5. 1/4 and 2/5 are not the same, so those two angles are not equal. Theta does not equal phi. Theta does not equal phi because those two ratios are not the same. If those ratios were the same, then we could say those angles were equal, because I know those angles are equal if those ratios are the same. These two triangles are not similar, so those angles are not equal. Number 5, consider a right triangle with acute angles alpha and beta. Well, I should probably draw a right triangle. There's alpha and there's beta. Explain the relationship between alpha and beta. Well, we know the sum of the interior angles of a triangle is 180 degrees, and I used up 90 right here. So alpha plus beta is 90. These two angles have to be complementary. They have to add to 90 because I already used 90 degrees up in that right angle. Then describe the relationship between sine alpha and cosine of beta. Well, the sine of alpha is opposite over hypotenuse. The sine of alpha is opposite over hypotenuse. The cosine of beta, when I input beta, I get adjacent over hypotenuse, x over h. So we see from this triangle here that the sine of alpha equals the cosine of beta. And this was known in Common Core geometry as our co-function relationship, hence why it's called cosine. We know that the sine of a complementary angle is equal, the sine of an angle is equal to the cosine of its complement. The sine of an angle is equal to the cosine of its complement, and the other way around. The cosine of an angle is equal to the sine of its complement. It's that co-function relationship. Because both of these angles will always add up to 90 degrees, the sine of that angle is the cosine of that angle there. This is just some review to get us back into some right triangle trigonometry, because tomorrow we extend our idea of trigonometry to beyond just right triangles into any angle. We start inputting any angle into our trigonometric functions.